Hello. Nidhir. Hi. So we'll just try this once. I'm just recording a video. I was hoping that we could have live stream today, but that does not look like it is possible immediately. Maybe from next time I can maybe live stream and just send you the link right away, and then it is easier that way. This is of course like just tell me if this works a little bit better because you can now rewind and like just check whatever I'm saying again. Okay, let's get started. So this is about the GPs that we are talking about, right? We wanted to revise the nth term. So the example that we were discussing was this one. Hopefully you can see it here. Yeah, there's a little bit of lag, but I guess it's okay. So the first term that we said over here was 3, and then we went to 5, then we went to 75, then 375, and then we sent the general term. So this is the first term, this is the second term, and our objective is to find the nth term right here. Oh, how is it called? So we know from our discussion in the previous class that the nth term should be called r to the power of n minus 1. In our case, it will be simply, let's check. So we want to find what will be the general term. So if we want the first term to be 3, then the nth term here has to also be this first term when n is equal to 1. And then when n is equal to 2, then the second term has to be the nth term, and so on, right? So we should be able to put in something in this n right here, right? And then we should be able to just find it out. Okay, so we want the formula for the nth term here. So what number should we put? So if we say it should be n here, right? Now in that case, let's just try. So if we put n equal to 1 here, then the first term we get is 3 into 5, right? Which seems like the second term. If you put 3 into 5, if you put n equal to 2 here, then it is 3 into 5 square, which is 25 into 3, which is 75, which is the third term and not the second term. So we want to be shifting all of these by 1. So this is how we shift it, right? N minus 1. Now if you put n equal to 1, you will get n minus 1 equal to 0. So 5 power 0 it will be. So 3 into 1 it will be. So which will give us 3. And then so on. And then it will give you 15 and so on. So this is our general term. Okay. So this is all fine. We discussed this last time. Now we'll move on to the sum of a GP. So let me go on to slide 14 here. Okay. So sum of a GP, the first term is A, second term is AR, third term is A into R square, which is 2 times the ratio, then 3 ratios, and then so on, till of course n terms you are trying to add up. So the last term will be n minus 1. Just to repeat, this is the first term, this is the second term, and then we have finally n terms, right? So n terms ka sum. So the subject is sum of n terms of GP. That is what we are trying to find. So because it's a sum, then we just simply do plus 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 and then directly till s, right? This is what we have to find. So of course it looks like it should be a1 plus r square r cube. If I take the a common out, then this is what we are looking at, right? Now we want to find a good way to sum this inner bracket of r square. As you shall see, like let me just skip to the result. It will come to a to the power of r to the power of n by r minus 1. I'm just writing it down so that you explicitly get it. Now, how we get it is what we are going to discuss now. It's not a very tough derivation, but what we can see is when when n is equal, okay, let's just start. Let's just try to find out how this comes, right? So let's just call this number, say, a number d. So d is what we have to find, 1 plus r square till r to the power of n minus 1. Now these are all math tricks that I will do now. So look at this. So I write d again, which is same as saying 1 r plus 1. But this time I find r times d. Okay. Now that means all of these n terms have to be multiplied by r. So 1 becomes r becomes r square becomes r cube, and finally r to the power of n minus 1 becomes r to the power of n. So let's try to write it down. So this becomes r square, r cube, and then finally r to the power of n, right? So one additional thing that I do is I don't write it like this. Let me rewrite this what I just wrote. Okay, but I shift it. So r I write here. So I'm shifting this here, right? So this r that I had written previously, I'm just writing it again. Then r square, and then finally this is r to the power of n minus 1, and then there is another r to the power of n term, right? I can always do that. Okay, and now I just add them term by term. Sorry, subtract them term by term. So minus, 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 and all of them are minus. So all of these terms, the middle term get cancelled. Everything gets cancelled in the middle. You see, R is cancelled. So we finally get the first term, this is remaining, and the last term here is remaining. So what you're getting is this 1 minus r to the power of n, which is on the right hand side. On the left hand side, uh, it is d. Oh my god. It is d minus r times d. Okay. So d, it's 1 minus r, and then you will finally get this, and then finally your d becomes 1 minus r power n by 1 minus r, or which can also be written as, if you take the multiply by minus 1 on both sides, which is r power n minus 1 by r minus 1, which is the same thing. Okay, so whatever you get here is rd, and we said that this one above was d, right? So if this d we have to multiply by a, which we are doing here to get the s. So this is the derivation of this formula, right? So this is the sum of n terms. So let's try to use this. Let's try to see it in an example. Say we have this term 3, 5, uh, sorry, 3, 15, 75, and we have to find just the sum of these three terms. So these terms in a GP? Yes, they are in a GP. And we have to find S3, right? Okay, let me just, you are not able to see it. Okay, now you are able to see it. So 3, 5, 3, 15, 75, this is a GPS, and we have to find S3, right? The sum of these three. Of course, we know colloquially that the sum should be uh, 15 plus 75 is 90, and 90 plus 3 is 93. Now, but we also want our formula to give this out, so we'll just run it through. So what we want to find is S3. So for that, we know that the formula is A r power n minus 1 by r minus 1. Okay, here r is equal to 5 and a is equal to 3, right? So you should recheck that, but then this is good. So let's try to find what S3 looks like. So let's just put in the numbers. A is 3, R is 5. Here n is again equal to 3, right? Because we want to find S3. So 3 5 by 5 minus 1. So this is equal to 3 times 125 minus 1 by 4. So that's 3 times 124 by 4. Let's try to simplify it. This is 62, this is 2, and then you have 31. So you have finally 3 into 31, which is 93, which is exactly same as what we should have gotten, right? So I'll give you some more questions in the worksheet, but for now this much is enough. For the sum, let's move on to the next topic, which is the sum of an infinite series. So if we look at say a geometric progression like this, 1, 1 half, 1 quarter, 1 by 8th, 1/16th, 1/32, and so on, right? And say, so we know that, so let's look at this as a GP. So the first term A here is 1, and R of course here is half, right? And what it looks like is every time, because every next term will be the previous term multiplied by R. So So the next term will be half as big as the first term, and it looks like all the terms are getting smaller slowly, right? So it looks like so if I try to take a sum of these terms, it will look like the sum is reducing. The sum is reducing to increase. Basically, what I'm trying to say is, so if you try to add only one term, this is 1, then sum of the first two terms will be 1 and half, which is, oh, you can't see anything. Okay, let me just repeat that once. So I'm considering this series 1 half